And welcome, guys, to another little session of our little tower defense game. Now, as you can see, we have our nice little layering system going on. Now, in this, we are going to talk about layers and how I've managed to get our building system where I can click anywhere close to it, and based on a size, it will not overlap. Okay, I can never get these objects to overlap. And further on, I'm going to be discussing how we can do towers that require power each shot. Okay, now we're going to start doing a lot of power management, bullet management, and stuff. So that way we've got more interaction with the player and stuff. So I actually have to have these squares out here like this that's indented, because when the enemies come by, we actually will use power per shot. Now each tower has a capacitor thing, so it doesn't require power each frame and stuff. Okay, I've lowered the amount of times that this refreshes to a whole bunch. Okay, and we'll have shopping where we can buy stuff. Ah, bless me. Now, in this video, we are going to refactor our building system so we don't overlap game objects. And, you know, after we've done that, we're going to move on to the next, because these are the second phases of the system, and we're going to keep adding and adding and adding. But in this phase, I'm going to show you what the difference is between a data layer, something that's in the background in memory, versus what's here in the UI system right here. Because this script right here, as you can see, is very, very small in here. So let's open up our editor and stuff, and let's see how this building mode works here. Okay. And it's going to do a stupid black screen because it's dumb like that. Okay, so here is the old script with a few other new stuff, but look at this. We have this. We don't have a list no more in here, or this vector. So look. I'm going to go delete here. This isn't used yet. This isn't used yet. Still testing. Okay, so we no longer do that. Okay, but you see a few other stuff, which is building data dot parenter dot this dot. Okay, so we're casting something from here to another script. Okay, well, let's look at this script first. We got the enumerator. We've got the spawn, the initial spawn. Well, guess what? This is bye-bye, gone. We have this static bool is taken, gone. This, gone. This, gone. This, gone. Okay, this is our update. Guess what? This is practically all gone too. So, wow, we just shortened our code like a whole bunch. And you're probably going like, well, what the heck's going on, right? Done. Okay. And we're done in our fixed update. Guess what? This is all gone. Okay. Now we have another one, can build. Guess what? Gone. This one, gone. On Gizmo, testing code for just in the editor, gone. So this script is actually really, really small, right? I mean, it's sickening how small it is. But you're probably thinking, where's the actual functionality going on? Now, this is exactly... Wait, why do we have a event system? We're not using the event system, right? No. So guess what? this is now our new script that's in building mode on the panel itself. This is a mono behavior. This is the visual layer now. Okay? So everything works kind of the same, okay? But in the start, we're doing stuff, right? We've got game behavior switch, which we've already seen. This is our static reference to this building mode script. That's fine. But now we have a new script here, which is building data.parenter.this.p object, which is parent object for short. And you're probably like, wow, this is really, what's this building data here? This is our data structure here. Now this is due to we need a layer that's completely just data itself. Now you're probably thinking, well, this seems like a complete waste of time. There is a benefit to having this class this way. See this public static class right here? This always exists from the start of the program. From the very beginning of the program, it exists. So as soon as you load up everything like the game and you double click, this automatically exists. Now you're probably thinking, why would you want it to exist all the time? Well, if you actually think about it, in Unity, when you do a mono behavior, okay, you go from one level to the next. A lot of the same functionality that we're going to have for every single level is going to be the same, right? Because we're going to have, buttons and all this stuff. This is a tower defense game, so we're always going to be building. So it makes no sense for us to go from one level to the next. Well, when you do from one level to another level, it will unload everything, every mono behavior in the game and stuff like that. It just deletes it all, and when you load up a level, it instantiates stuff. So by having this class this way, this always exists, so it never unloads. You only change the values in it. So here's another benefit to it. You see this asset bundle right here? This asset bundle right here? If this is referenced right here, it will never unload. So in the start of the program, that little start screen where you go player, please push the button, we can have this load in the background from the very beginning of the game and just keep the bundle around. Because these are only for buttons. I mean, this is really small, right? So the asset bundle will be very, very small. It just stores UI elements, right? So it, for this right here, we're going to have the asset bundle. It's going to be very small, okay? Because it's only dealing with building buttons, okay? And you can always put this asynchronously in the background. And then when the level loads, this is already here. So when it's already existing, it just goes straight to instantiate your buttons and stuff like that. And your loading time, because this always exists, goes clear down, like very, very down. And two, if you had this mono behavior and you had this here, well, guess what? When this class right here unloads because it's mono, it will have to load up all this information again and again and again, which kind of is stupid, right? I mean, in all honesty, it's stupid. Versus, here's what I'm offering. This list right here, we just clear it from the beginning. This bundle sticks around forever. That's fine. This layer mask, it ain't going to change. I mean, why would we change the layer mask at all? I mean, most of the time when you go from one level to the next, you're just going to duplicate the level and just change the geometry and stuff, make it look different, and that's about it. This queue right here, this queue is to, in the game, we we'll have actually let's just do this, okay? Public game object, that's our building object, what we're going to build, how much it costs and stuff. That's not changed. We've got a list. This list right here is every button that we already have, okay? Every building asset that we have, we just keep a reference to a name, right? Because once that name's taken, it won't duplicate a button of the same kind. You know? And two, when we go to serialize, well, guess what? We've got the name of all the buttons. So in the very beginning of it, we load up a list of strings like this, and then we just instantiate them all, okay? All in one go, okay? Our asset bundle, which we just load, right? Our vector3 size is, okay, when you instantiate a game object like this, we're going to have a building or a tower or something like that. So they have all different sizes. So when we do a check to make sure that something is in that area, we need to adjust this accordingly, right? So that's what that's for. The layer mask is for layering out stupid stuff, you know. That's pretty easy. I mean, if you know about raycast and layer mask, right here, you'll be able to figure this out beautifully. Not very hard. This queue right here, this queue is designed for one specific reason. If we go down here to our update, in our update, if queue.count is greater than 0, we make a string variable here, and we equal it to string spawn queue.dq. What this does is it goes through the queue, it takes this string out of the queue, just like remove from a list. It will remove it from the queue and go, hey, what do you want me to do with this string? So we do add button asset, and we bring it the item name, okay? Now, the reason why I did it this way is, let's say we have an array of strings and we want to instantiate like a whole bunch, like in our saving system. Well, instantiation is very slow. If you do a whole lot of it in, you know, a single frame, like in a for loop or something, it will slow down your program very, 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 very much, okay? So, very bad to do a whole lot of instantiate in a single frame. So, in this update loop, if it's greater than 0, we pull a single one out. And this will always happen. This will always happen till the queue is empty. So, if you're thinking about it, you know, you want to move a stack of, like, let's say a case of pop, right? But you got to move them one at a time. Or are you going to move the whole entire case? Well, the case is busted, right? So, you know, you're sitting there picking them up one by one, and that's what we're doing. That's the perfect explanation that I can come up with, okay? So in here, we've got a vector3. Okay, let's go back up to the variables. Public static parent. Okay, this is the parent thing. The thing that we're in because this is a more of a C class than a mono behavior, we can't use this dot parent to us. Okay, we have to give it a transform to parent it to, and that's where this comes into play. All right. And then we got this static enumerator that just gets our asset bundle and places it in this variable. Because if you don't place it in this variable, it'll get garbage collected when it's not used for X amount of time, which really sucks. You know, I mean, it does. And then you have to worry about all this other stuff. No. Let's just put it in a variable so it's referenced, so that way the garbage collector just ignores it all the way around. It just goes, no, ain't gonna do it. Boom, there you go. And then this get asset, oh yeah, this get asset is here for the initial spawn. We have to have buttons in the queue some way, so this initial spawn is here. That's the only purpose that it has right here. We hard coded 2 buttons. That way the player has something to start with, okay? Is taken? Well, guess what? That's exactly what it does, okay? Which I don't think we actually even use this anymore. No, I don't think we. Oh, actually, I think we might in the money system or something. We have this check for some reason. I'm pretty sure that it's here for some reason. And we do a button asset. Okay, static. This isn't public, so it's not accessible outside of this class. And we do just string able. We make sure that it's not in already here. Hence why we have a list in the first place. And we just go, hey, guess what? Let's add it to this list and instantiate it from the asset bundle, okay? So you have to make the button inside of Unity, inside the editor, which is no big deal because it's very intuitive. You just, it's the push game object. That very simple, very simple. Okay, now this is a function that you guys haven't seen. This is how we are adding stuff from the unlock. When you go to research something and it goes to unlock, we use a script called unlock build. Okay, and it goes queue that, and we just go item.build content. So the item, what it is, and then hey, what's the build content you want me to unlock? Very simple script. Very easy. Okay. Now, this one is a public update. Now, because this is a static class like this and things, we don't get callbacks like start, update, and everything else, which is good because that's the hint of why we have this class exist in the first place. See, in our update, we just go data by building data.onUpdate. So it will update every single time this is active and in build mode. Hence, it's pretty much the same exact way we were getting updates, but we're just extending it. We're using this class to go, hey, update my static class. But I don't want to hard code this as an update all the time because we don't need it to be updated and doing raycast and all that stuff every single update when we're in upgrade mode or some other type. Okay, each mode, we've came up with we've used a finite state machine to go, hey, if we're in build mode, use this script, update, and everything else. If we're in upgrade mode, we use upgrade script. Nothing else. Making sure that we only have one script active at one particular moment. So we get rid of all those checks. If we're in build mode, if we're in this, if we're in this, if we're in this, that. We don't need that crap. We don't need that junk. We'll be good. So let's go into our update again. So if we're queue, then we do add buttons. Okay. This vector right here, we're creating a new vector 3 right here, pointer, and we're doing mathf.floor to int. Okay. Point hit.point, which hit.point is a static reference right here. This always exists, okay, and this is outside of a function, okay. This isn't made at runtime. This always exists because we need it to always exist. I don't want to do a bunch of outs and ins and all kinds of others. No. Let's just make it a member variable right here, so that way in this class, in this function right here, update, I can use just array variable, okay? Array variable right here. I don't need to do an array cast here. All I need is the information of where I hit. So we use hit.point.x because we're making our new vector 3. So all this is for a new x coordinate, okay? We use hit.point.y. We don't mathf it or nothing. We just use the y as is. Then we use mathf dot for z, okay? And what this will do is just make sure that we go from point to point. It's a nice even number. It gets that nice snapping feeling, okay? It snaps from one point to a next, to a next, to a next. And it's always even, okay? Now, we have an input get button down, fire 1, and can build, which is the same as it always has been, can build, which is this right here, which is just a member variable of can build, okay? We do physics box check pointer, and we do vector3.1 quaternion.identity, and then we use the layer mask that we have. And this returns a true or false statement, okay? True or false. If it hits anything, then it will automatically go to true, and it will not let you execute any of this stuff, okay? So GameObject.instantiate, because this is more of a C class and not a mono behavior, we have to go from GameObject.instantiate, BuildObject at pointer, our new vector3, quaternion.identity, and we get the location from here. Very, very easy. And we do cost, money cost, current cost, which current cost is the variable up here, which is our scriptable object for anything that deals with cost. And I think there's some UI elements. This class is going to be rewritten for stuff anyway. So we're going to have that discussion when it comes time. So that's the update, okay? So let's look at this, okay? We got a raycast hit, all right, which is there. And we want this to be accessible all the time, okay? When we're in update or any other thing, we always want access to this, okay? Can build public game object hit.target, and what this does is if I hit something that is not the ground, then it changes this variable, and I change the conditions, okay? You'll see that in a minute, okay? If event system is over the UI, can build equals false, and then we return. We return early, so none of this other stuff executes, okay? Now in here, we do array in the middle of the screen at the mouse position. This doesn't change. But here's the thing that really goes into it. Physics.raycast, ray, and then out hit, and we do 10,000 or so, okay? Now the out hit, you always got to do this way, but it's fine. Just it outputs it into this variable, okay? So hit.transform.gameObject does not equal null if we didn't hit anything, like let's say we were at the edge of the level and we went into outer space or something. If we didn't have this check, it would probably give us an error, because it's always checking to make sure that we hit something if we just had this code or this code. So we do hit target equals hit.transform.gameObject, okay? Now here's the conditions that's really cool. Can build equals can build current cost hit.transform.gameObject, and then game layers dot build layers, okay? So can build is a function that checks the cost, the game object, and what layer we hit. Okay? So if the amount equals null, return false, because it just is bad. We don't have an amount thing, and we just need to return it early. Now, for money.needAmount, we are comparing the cost object equals true, which what this does is check to make sure we have enough money, and then return false or true. Okay, and go.layer equals layer, which is the game object that we passed in, okay, or hit, and we compare what layer it's on. If it equals this integer layer, which this is what this returns, is an integer, then it returns true or false, okay? If it returns true, then we have enough money. If for any reason these conditions never get met, then we automatically, by default, always return false, okay? And that's can build, which is pretty easy, okay? Now we've got this public static push to build, which requires a game object and a cost object. All this does is set the variable, okay? These right here. What we're going to instantiate when we hit the button. That's it. Very simple, okay? We talked about build mode. We've talked about that, okay? Now we need to talk about push build object. Push build object is a button. That's all it is. We do a prefab for the tower, a prefab that we fill in for the cost object, which is a scriptable object, and then we do string info, okay? And all this does is do void set to build. We go data, building data dot push to build object, and we just put these two variables in. That's it, okay? Now this on pointer click and stuff, this happens because of these, okay? You have to have these interfaces in order for this to happen, to get pointer event data, okay? Now, you can not have these right now, okay? But you have to exit out of these, okay? You have to exit off that, okay, and just put this. But I always have it put to set build object, because this is just a regular script, okay? Just a regular mono behavior that you put on your button, and it just requires an image, okay? It requires an image. That's it. You don't have to do a button or anything like that. And the reason why I did this is if you put a button on, it causes a rebuild on the UI when it gets enabled or disabled. I want this to be pure data. I don't want to deal with the button unless I absolutely have to. Because the more stuff that I have to set in the Unity event system or anything like that, I don't like it. I want more control over our code by doing it myself like this. And two, I don't want this to be public. This has to be public, okay? But I don't want this to be public. I don't want these to be public. This entire thing is all privately owned by this class, because that's the way it should be anyway. And all this is responsible for is when we put an image in there with the game object and all that stuff. If I click on the image, I want this to execute. That's it. That's all this class is responsible for, which it's already responsible for quite a bit. I mean, prefab and a cost object. So yeah, that's how that works. And this class is always static. This is always available. So in some time or whatever, like, oh, okay, here's the great thing about this. This always exists, And thanks to how we have our update, let's say before the level even starts, we want to put everything in the queue, right? Well, we can have everything in the queue because of this update right here doesn't happen unless we're in a level, okay? Unless you call this from a specific script, this will never execute, okay? This is like a dead function until you have a build mode object here and it's active and things, okay? So if this is in the start menu and this is already in memory and stuff, we can slap everything that we need into the queue, okay? And then after the level is loaded, when this does its initial spawn and update happens, it will go through and do all the buttons, all the instantiation and everything else. But as long as you're not inside a level with these kind of scripts or mode scripts, then these stay dead. I mean, you could sit there and call up everything inside of it and it won't do anything really unless you've got this. The queue, you can fill this in, you can fill the build objects, you can fill the string list, this vector 3, you could do all kinds of screwy things with it. And it won't matter because the update doesn't happen. So it won't air out. So this is build. Actually, these two functions actually exist. But that's about it. This goes into panel object. Just these two functions. That's it. I named them all data object because that's what they are. They're data. Okay. But I'm not. Don't be too worried if you can't get this kind of stuff working yet, because we have to go over it in another video because it's part of the second wave of everything. So don't get frustrated and stuff like that. You can always go bloop and exit out stuff until the next video when we talk about that script. Because unlock build and this are different scripts. I completely rewrote a lot of the stuff for the research and the upgrades and stuff. I went with a more UI friendly setup for researching and stuff. So don't worry too much if it doesn't make sense. I will be doing the video where it will make sense because it's actually really good. It's actually, I'm pretty proud of how it turned out. Okay, so we have this all good, and you know, let's see what the time is. Oh, 33 minutes. Well, here's the thing. I don't want the video to go too super long, so I'm gonna cut it right here. But more videos will be coming out and everything else because I have it set up and things, and I'm pretty proud of it. And here's the thing about it. Here's what I'm. Here's my setup for my data stuff. AI's here. Our build buttons is simple. Here's our build thing. All we need is a prefab, cost object, and we'll put some info here. That's it. When we do our buy stuff, this buy thing is dynamically put in, okay? Where we can buy different resources stuff, that's dynamically put in. That's very, very easy. Where we can buy like a bunch of different stuff like steel and things like that with money, okay? That's not a big of a deal. Health tech is a very, very different class that will have to wait. But in research button, here's this base. In order to make another research button, you have to do the rate, that it will, you know, get to the point. Amount needed, which we can put to 1. Okay. Alright, the rate be 0.5. You know, it takes about 2 frames or something like that for it to complete. Who cares? You can have a message. The research tech that you need in order, you know, the next research that you're going to upgrade, you know, unlock when you hit this button. And the build content, the stuff that you unlocked for building, okay? And then there's another button. This is for upgrades. When you try to upgrade your tower, you need a certain name, okay? Which this is for upgrade content, okay? The next upgrade that you're going to be researching for is here. You type a string in, and then the message, and points and rates. Very easy. We use all strings because we're instantiating in our classes through asset bundles. That's why they're all strings. And 2, the reason why we want to use strings in this case is because they're very savable. We can use a binary formatter or anything that we want to save this kind of data. The stuff that we've already researched. Very, very easy, very, very simple. Okay? So, that's what's going to probably entail is the research panel, probably, or the upgrades. Because I've moved them and stuff like it. It'll probably be the research. That'll be the next video. But just to thank you guys for watching, and this is Wardon over and out. And you know, if you haven't hit that like button or that little bell below, hit that sucker so you don't miss stuff. But peace and take care, guys.